Good morning, folks.
Good morning, Mark. I was worried I was in the wrong room for a little bit.
Sorry, I was talking to Sage. He's not feeling well today, so we're gonna proceed on without him.
Gotcha.
Let's see. There's a couple more folks showing up, but it might be a small crowd. I was talking to Leo. We should try to re-advertise this meeting again to the list, since we've kind of been slowly losing people over the last year or so.
Yeah, that's a good idea.
Might be,
I don't have to repeat reminders anymore.
Yeah, I know. I've been getting lazy about it. I don't know if I should probably figure out how to automate that and just have it send one out. But yeah, it seemed like when we did that, we did get more people in.
Mm-hmm.
All right, somewhere in my mass of open windows here is the Etherpad. Let's see if I can drag it out. All right, here we go. So I did not quite make it through all of the no movement PRs this morning. Unfortunately, I was trying to do too many things at once and learned my lesson, but there's not a whole lot of new stuff going on. There was a brand new PR from Peter to reduce buffer list rebuilds during write-ahead log writes in BlueFS. And that actually could be a really good one to look at, because that will that very well could have an effect on performance with like small random writes, given kind of the patterns that we've seen with BlueStore. So anything that can reduce overhead in kind of in write situations like that is probably going to have a good effect. So I'm curious to test that one out and see what it does. There were a couple of ones that closed here. Josh, I think you looks like you closed a couple of them for CBT stuff Neha's been working on. So that's good.
Yeah, Scot's bench now works in CBT. Again.
Yay! Again. I'm not sure anyone was aware that it was broken.
Well, I assume it worked at one point.
Yeah, I think it sort of did. But Intel was the only one that was really ever using it. And I don't know how long they kind of kept up with it. But that's good. Is it maybe a question for you then, since Neha is not here? Oh no, Neha, you are here. So for either of you two, is it, how hard is it to kind of get it set up and running these days? Is it kind of all automated, or is it pretty?
So with Tuthology, it's all automated.
Okay.
But if you want to run it standalone, you just need to follow the instructions, which are pretty much there in a README in the CBT repository, to set up COSBEN separately. And so you just need to ensure that you set it up and start it, and then CBT should just pick it up from there.
Okay. So you do have to go through that kind of process of getting it running in advance before CBT comes in, and making sure that like it's talking amongst itself properly, or is that correct?
Can you hear me? I just lost you in between.
Oh, I didn't hear you. Maybe it was my end though.
Sorry. So yeah, so just to specify, so it's almost like FIO. So like FIO, you need to set it FIO separately and point the right directories to CBT to look at. So there are some dependencies, some packages that you need to install. So that is a one-time setup that you would need to do to run it separately with just CBT. But if you run it using Tuthology, the script does everything for you.
Okay. Good to know. it would be really interesting to see how different the performance results look from Cosbench and Mark Seeger's GetPut tool that we've got kind of wrapped as well.
Yeah. So I think it's true, since this was integrated, that there are certain restrictions when you run Cosbench using CBT. It lets you do a couple of things only, like read and write, or but it doesn't let you do all kinds of stuff that you would generally be able to do with just Cosbench. But yeah, I mean, it's worth trying it out.
Sure. Okay. For a lot of the stuff that I've done, I've been using GetPut just because it was easy-ish for me to get running and do standalone tests with. But if we can if we can show that Cosbench is better or more representative, it might be worth trying to make that kind of maybe more the default. I don't know.
Yeah.
Right now, go ahead.
Yeah, just I mean, I agree. I have mostly done like single node testing with it, so it might be worth trying out multiple nodes and all the kind of stuff that you generally do for RGW workloads. So with
Yeah.
Cosbench as well, and see where it's failing, and we can improve on that then.
Yeah. Okay, cool. Well, good job, guys. That was kind of suffering from bit rot, and it's good that somebody went through and figured it out.
Thanks.
All right, so we've got a couple of other things here. It looks like cache re-encoded OSD maps, which I haven't looked at all, but that sounds like it could be really good. I guess I don't know how much that was hurting the mon, but good to see it there, I guess. And then Radek just closed one of his old PRs, trying to improve Ceph auth in favor of moving toward NSS. So he's got a couple of these out, I think, but so I don't remember exactly what was in each one, but yeah, generally, I guess.
That comment. I guess it's actually moving towards OpenSSL from NSS. It looks like it's
okay.
a ton faster for the Cephx authentication stuff.
That would make more sense, because I thought that's what we were doing, but then saw this and I was confused. But yeah, all right. I mean, actually, just no, I won't change it here because someone can change the title and fix it. But there used to be like a licensing issue, right, Josh?
Perhaps a long time ago, but nowadays not so much.
Okay.
RGW's already started to use it for some of its encryption stuff, I think.
Okay. Well, good. That sounds hopeful.
Yeah, I'm glad seeing some good results from it.
So the other two updated things I see here are Radek's huge pages thing to limit page faults. Yeah, I guess we'll see how much that actually helps in practice. And then this other one from Adam, which is something about hashing, I remember. Let's look at it. Oh. Yeah, he changed a bunch of stuff here. Sage was not totally sure about this, even when he was reviewing it this morning. There was a user, though, that reported a pretty massive improvement in the field when he was testing it. So I guess the question is whether or not this is actually safe to do. Anyway, that's it for updated stuff. There's a bunch of no movement stuff here. Like I said, I haven't gotten through all of it, but usually this far down the list, there's not too much that shows up. most of it's usually just stale. So not a whole lot to discuss about it anyway. So that's it for PRs. Anything folks would like to talk about this week? If not, I can talk a little bit about some of the things I've been working on, but if we don't have anything else, I guess I will start. So I have been looking at caching, a lot at caching. I think previously I'd mentioned that I've got a branch where I am doing some auto tuning of the different caches that we have, both the onode cache, the buffer cache in BlueStore, and then also RocksDB's block cache. And there's been some kind of interesting behaviors that I've seen when doing this. One is that recently we decided to enable buffered writes by default in BlueFS. And the reasoning for that was that when you, in RocksDB, when you're doing a compaction, if you can't store all of the SST files in the block cache, you end up having to read them in. And that means during compaction, during like a really heavy write workload, you might see a bunch of reads happening from the disk. One of our partners saw this behavior and was not happy about it. So by having buffered writes, you can ensure that if you have a lot of page cache available, that those SST files end up being stored in the page cache, and a read, if it's not in the block cache, in RocksDB's block cache, will come from page cache rather than the disk. So that essentially eliminates that behavior if you have enough page cache where you don't see those reads really happening anymore. That is good in a situation where the buffered writes don't hurt you very much, and the ability to have those SST files put into page cache helps. So if your block cache isn't very big and you've got a lot of page cache and your CPU is fast enough so that the buffered writes kind of don't have a whole lot of overhead, you can see some benefit by doing that, especially if your devices can't absorb the reads really easily. The flip side of that is that if you don't have a lot of page cache and or you have enough block cache to store all of the SST files anyway, and potentially if your CPU is impacted by doing buffered writes instead of just doing direct IO, you may actually see a really big performance penalty by doing buffered writes instead of direct writes. And it turns out that on my desktop machine, where I've been doing a bunch of this cache balancing testing, we do see that. On an RBD workload that I've been running, turning on buffered writes is actually causing us to drop from like 19K write IOPS to about 12K. So it's a notable impact. We don't see that same kind of drop on our big fast test boxes in the lab. It's kind of a negligible impact even when you've got plenty of block cache and you wouldn't see the reads anyway. And potentially when you do have a situation where you're reading SST files from disk versus reading it from page cache, having them in page cache might actually help more than it hurts. So the gist of it is that this is all really complex. My thought right now is that with the auto tuning enabled, we might be able to do a better job of keeping SST files in cache and kind of noting this behavior and maybe being able to avoid the page cache enough that going back to direct writes rather than buffered writes makes more sense. So that's kind of what I'm hoping right now. As of current master, we still have buffered writes enabled. We did that like a month or two ago. I'm not sure if that's the right answer or not. It certainly lets us avoid the behavior that our partner saw, where they were seeing these reads during writes, so long as you have enough page cache available. But whether or not that's really what we want to do, I'm not convinced. It kind of moves us back toward relying on the kernel rather than kind of doing things ourselves in a smart fashion. So anyway, I've got lots of data. I'm collecting more data. Right now, the auto tuner is maybe faster in a couple of situations, but I'm actually not seeing a huge performance difference. I'm a little disappointed about that, but I am seeing much better behavior in the caches. It seems like it's having a positive effect in the way that you'd expect on how the caches are balancing and kind of laying things out. So my hope is that it really is actually helping. It's just that right now we've got other things that are kind of holding us back, maybe before, at least on this hardware, before seeing a cached read versus a read from the SSD making a big difference. And maybe just the SSDs that I have in here are pretty fast, so it might just be that they're so fast they can absorb everything, and the CPU is the limit, which definitely seems to be on this box. So anyway, that's kind of where I'm at with that. Any questions on any of that? Okay. Maybe the only other thing I'll mention is there was a good topic last night that Josh had at CDM on logging and kind of the performance implications of what we currently do and potentially things that we might be able to do in the future if we moved over to either trace points or like a binary log format. So that was probably recorded, I think, so it might be worth people's while to watch that if you have any interest in that whole topic.
Yeah, I think it was recorded, and there's some brief notes in Etherpad as well.
Cool. Well, I don't have anything else, guys. Any last minute thoughts, or should we end early? All right. Sounds like we're ending early. Yeah. All right. Have a good week, guys, and we'll meet again next week.
All right. Thanks, Mark.
Yep. See you later.
Later on.
Thanks.